immunity. We can't talk about the lymphatic system without talking about immunity. They kind of go hand in hand. But what really is immunity? Well, maybe you're thinking it's fighting off bacteria, or getting rid of dead cells in your body, or whatever comes into your system needs to be gotten rid of. The idea is immunity simply is resistance to disease. It doesn't matter what form it takes, whether it's bacteria, virus, a parasite. You're trying to get rid of things that should not be there. And this occurs in two main ways in your immune system. You have what's referred to as innate and adaptive immunity. Now, in the case of innate, this innate defense system or innate defense mechanism is going to be against anything and everything. It's not specific. But while you have then also the adaptive defense system, this one is specific. It's going to make sure that's targeting precise and specific items. So a certain bacteria or a certain virus or a certain pathogen or a certain parasite, whatever. But when you look at the adaptive, it has to be able to target a certain thing. It can't just say, I'll target everything. It has to be specific. So we definitely need to delve into those two a whole lot more as we move through these different parts of lectures. But let's start with our defenses. Our first line of defense. Well, what's our first line? Skin, sure, our membranes. It's what's covering our body. So our external body membranes. Skin, mucous membranes of the mouth, in the nose, around the eyes. Everywhere that's covering our body, creating an external barrier. That's our first line of defense. Now this is innate because it doesn't matter what it is, it's going to try and prevent everything from entering in. Second line of defense, things like antimicrobial proteins, various different phagocytic cells, and pretty much any other cell that's just going to simply destroy. Now, again, not specific. This is innate. Inflammation also helps out here. Because inflammation, when you start to swell, it helps kind of contain things, keep things in a certain area. Helps to also bring in more of these cells. All right, first line, second line, both are innate. But the third line of defense switches over. The third line of defense now is an adaptive defense. That's because the third line of defense, they're looking, and it'll take more time to find these foreign substances, but it's specific. You're targeting a particular antigen, a particular pathogen. So yes, it takes longer because you have to know which one you're targeting. You have to identify and then react. The skin, it's always there. It's on 24/7. But if you start looking into things that get past the skin, into your blood or tissues, it takes a little time to recognize and then react. So that's the adaptive defenses. So things that fall into both categories. In the innate, we've already mentioned these surface barriers, skins, membranes, things like that. The internal defenses, though, that's that second line. These are the things that are phagocytic. Inflammation is here. Antimicrobial proteins. Things that don't discriminate. They simply attack everything. NK cells. NK cells are natural killer cells. Again, doesn't matter what, they're going to attack it if it shouldn't be there. But then that third line, remember, was adaptive. That's your B cells and your T cells. Things that will be specific to a particular antigen, to a particular pathogen. Remember back to talking about the blood chapter. We talked about B cells and T cells coming from a particular type of white blood cell, remember. This is now going to delve a little bit further into that. So looking at how our body's defenses are built and structured from general to specific. Now you've seen this before. This came from the blood chapter. But hopefully remember, we start with that hematopoietic stem cell, differentiates into 5 different white blood cells. We're focusing over here. Notice B cell, T cell, natural killer cell. They're all coming from this lymphoid system, the lymphoid cells. So this one particular one has a lot of defense mechanism here. That's what we're just talking about. Now, do the rest of these still deal with it? Well, sure. Monocyte goes to a macrophage. So that's definitely. Eosinophil, basophil, neutrophil, they can all attack certain things, sure. Red blood cell isn't really going to attack anything, so that's more dealing with oxygen and carbon dioxide. And then you got the platelets. They're not really attacking, they're trying to prevent damage from loss of blood. So we're really focusing into the white blood cell area here. That's what we're looking at for these defense mechanisms. All right. You're saying, bone marrow, how does that have to do with this? Where do you make all the blood cells? A lot of them are made in the bone marrow. So this is most of your hematopoietic functionality, which means most of your blood cell formation. Now, almost every one of your B cells is going to develop inside the bone marrow. Notice I didn't say T cells, B cells. So these B cells are developing inside of this red bone marrow. Now, it's not every single one, but it's the vast majority. The thymus, the second component that's going to help with development and production here. Now, the thymus itself will change with age. So initially, in infants, it's found in the neck, heading down to superiorly and anteriorly to the heart. So it's up in this region. But as that infant ages into childhood, the thymus can actually increase in size a little bit to its largest point. But then as you continue to age, going through adolescence, going into early adulthood, and so forth, it gets smaller and smaller and smaller. It atrophies with age. Well, you're saying, hold on, why does this need to atrophy with age? Why does it get smaller? Think about that as we continue on. The thymus itself is going to have these outer cortex and inner cortex of these lobules. They're going to have different functions here. So outer cortex, inner medulla. I think I missed that one before. So outer cortex, inner medulla. The cortex is looking at lymphocytes and macrophages. All right, so maybe that gives you an idea of, hey, what's this doing? Lymphocytes, macrophages, we're destroying immune functionality. But then if we move on, medulla is containing regulatory T cell development. T cells, remember, are also immune functionality. So now we have both the medulla and the cortex dealing with immune functionality. So looking at it itself, you can see kind of right here, that would be the medulla inside, and then cortex is outside. So looking at the different structurality here of the thymus, sitting just superior and anterior to the heart. And as you go through adulthood, it's getting smaller and smaller. So now the reason this thymus is important and the reason it differs from a lot of the other organs of the lymphatic system is because it's going to actually function only in T cell maturation. Now, I say only T cell maturation. That's important, don't get me wrong. But there's no actual fighting of the infections here. The T cells aren't going to be activated and fighting inside the thymus. They do that throughout the rest of your body. So this thymus has immune functionality to it. So again, the question comes back to, why is it atrophy as you get older? We need our immune functions. It atrophies as you get older because your immune system as a whole is getting more and more efficient. You're developing these memory cells that can recognize foreign pathogens that you've already seen in the past. So therefore, if you have a reaction again, hey, I know what that is. Let's get rid of it faster. So as you get older, you don't need the same functionality of the thymus because your body's building up this library, building up this whole immune system as you're going through childhood into adulthood. So you're not directly fighting with the thymus. It's getting these ready and then sending them out. So these actual thymocytes, the cells of the thymus, the thymocytes allow the T cells to become immunocompetent. Now, immunocompetent means they are fully functional for the immune system. So by sending these immunocompetent T cells out, they can function like they should, and they do not need further development. So the thymus really is developing your T cells. So from the thymus to the red bone marrow, looking at some components of our different defense systems in our body. From the first layer to the second layer to the third layer of defenses, innate and adaptive.